Hi everyone, we are going to talk about inscribed angles today. So an inscribed angle is an angle inside of a circle where the vertex is a point that's on the circle. And I put in here in the notes, it's very important. It doesn't mean the vertex is inside the circle. It means it's a point that's directly on the circle. So right here, this is a picture of an inscribed angle. Because that point B, which is the vertex of the angle, is a point that's on the circle, literally like on top of one of the points that makes up the circle. So remember, make sure you know it's the difference. It's not any point inside the circle. It's a point on the circle. That's what makes an inscribed angle. So right here, angle ABC is an inscribed angle of circle O. That's how we would say it. Now here's another vocab word for you. The intercepted arc. I mentioned this in the last day of notes, but I wanted to put it into your notes today. An intercepted arc is the arc between the two lines formed by an angle. So in this picture, the red arc, arc AC, is the intercepted arc of angle ABC. And we're going to use both of those phrases in our first theorem for today. The measure of an inscribed angle is half the measure of its intercepted arc. And again, it makes it very, very simple. So throw some numbers in there. Let's say I told you arc AC was 50 degrees. Angle ABC is 25 degrees. That's half. Or let's say I did it backwards. Let's say I told you angle ABC was 20 degrees. Then arc AC is 40 degrees. Now what I want to do next, let's combine that with what we learned about central angles earlier this module. So in this picture, we have all three things we've been talking about. We have a circle, we have a central angle in green, we have an inscribed angle in red, then we have an intercepted arc in blue. Now that intercepted arc is being intercepted by both angles. Like if you look at them one at a time, the green angle, like this, is intercepting the blue arc, but the red angle is intercepting the same arc. So what I would say, and I kind of color-coded the notes to match the picture. I said in the picture, the central angle, green, and the intercepted arc, blue, have equal measures. The inscribed angle, red, is exactly half of them. So again, throw in any numbers you want. Let's say the blue arc is 100 degrees. The green angle is 100, the red angle is 50. I mean, it's that simple. Green and blue are the same, red is half of those. Or in symbols, we would say the measure of angle CAB, green, equals the measure of arc BC, blue, and they both equal 1/2. Actually, that's not right. Let's fix that. In this case, they would equal 2 times that one, because that one is half of them. I typed up 1/2, but it's actually 2. They both equal 2 times whatever measure of angle CBB is. So here's an example. Here's a picture. Let's find the measure of angle BOC. So I look at the picture. Let me kind of highlight in red what we're talking about. From B to O to C, what is that angle measure right there? Well, I look at the picture and I say the one I'm being asked about is a central angle. The one that was in the picture, the 55, is an inscribed angle. They both have the same intercepted arc. That means, by our theorem, the one that we're looking at, the 55, is half of the one we're looking for. Or basically, my answer, very, very simple, 55 times 2. Answer is 110 degrees. All right, let's make it a little bit trickier here. We have several different inscribed angles in this picture, and we want to find that question mark right there. So I asked you to find measure of angle BZY, which is the question mark in the picture. And I look at it and I say, okay, well, it's an inscribed angle, so it's going to be half of its intercepted arc. Well, if I look at the question mark angle, its intercepted arc is going to be this one in red right here. So if I can figure out what that arc is in red, my answer is going to be exactly half that number. So I think back to what we learned earlier in the module. I know that circles always add up to 360. If this is 90 and this is 144, then I could add those two together and subtract from 360. It'll tell me what's left over for the red piece. So let's do that. Let's do 90 plus 144. That would be 234. And then let's subtract that from 360. 360 minus 234 would be 126. So I just figured out the red arc is 126 degrees because those three need to add up to 360. 90 plus 144 plus 126 has to equal 360. Now the answer to the question is going to be half that number. Once I realize the red arc is 126, then we can use that to find the measure of angle BZY, which is what I'm trying to find, by just multiplying by a half. A half of 126 would be 63 degrees, 63 degrees actually. So our answer is 63 degrees. A little bit trickier than the first example because you had to kind of put some different, there's more than one angle showing, but it's all about the relationship. Inscribed angle is half of the intercepted arc. Okay, last example here. We have inscribed angles again, intercepted arcs again, but this time it's a solve for x question. And in fact, that's what we're doing. We're solving for x. So first of all, I've talked to you guys a lot about this here, a lot about this. So a lot of people will look at this question and without even thinking about it, they'll go, oh, I see 7x, 7 plus 7x, I see 12x plus 2, I'm going to solve for x. 7 plus 7x equals 12x plus 2, and they're going to solve for x. If you do that, you got the question wrong. Because those two arcs are not equal. If you look at them, the one on the bottom is actually bigger than the one on top. If you say two things are equal when they're not equal, it doesn't matter how much work you do, you're not going to get the question right. So what we need to do is figure out a different relationship here. Now what I notice in this picture is that this point right here is the center, which means this line segment right here is a diameter, HF, which means it's going to cut the circle exactly in half. So I just found my relationship. The 7 plus 7x and the 12 plus 2x are not equal, but since they equal together, equal exactly half of a circle, they have to add up to 180. So what I'm going to do is I'm going to take this and this, I'm going to add them up and set them equal to 180. That's the equation I want to solve. Those two arcs together have to equal half of a circle, or 180. So I'm going to do 7 plus 7x plus 12x plus 2 equals 180. That's the equation I want to solve for x. So let's combine our like terms. I have a 7x plus a 12x, that would be 19x. I have a 7 plus 2, that would be plus 9, and the whole thing is equal to 180. I will subtract 9 from each side, and I get 19x equals 171. We'll divide by 19, and x actually ends up equaling 9 here. So our final answer was x equals 9. And again, at this point in the question, remember, you always check what you were asked to do. I was asked to solve for x. I've done that. I'm done. If I had asked you what is the measure of angle GH or GF or arc this or arc that or whatever, you could go back and plug x in and find that. But for this question, we're done. We did what we were asked to do. And remember, don't automatically see two things and set them equal to each other. What I crossed out in blue on top is a very, very common mistake. If you said 7 plus 7x equals 12x plus 2 and solve for x, you got the wrong answer. If you add them up and set them equal to 180 and solve for x, you get the right answer.